Alright, hi guys. Today we're going to be talking about parallel lines and proving triangle congruency. Both of these items are reviewed from Math 2, so let's get to it. So what is a parallel line? So this is something from long ago. It's two lines with the same slope that will never touch or intersect. Alright, so that's a parallel line. We got that through. So let's look at this image. So we have two parallel lines and it's cut by a transversal. So to answer this question, this is called a transversal. Alright? And we're going to be referencing back to this picture a lot. So things that we need to know in order to get on with the rest of the unit is that we have these 6 things. So vertical angles. Vertical angles are always congruent to each other. So an example of a vertical angle is 3 and 5, or 1 and 7, or 2 and 8, or 4 and 6. If you get this idea, it's when there's two lines that are crossing each other, and the angles that are across from each other diagonally, that means those two angles are congruent. So we could say angle 2 is congruent to angle 8. All right. So now we have linear pairs. Now linear pairs are not going to be congruent. They are going to be supplementary. So these are supplementary. And what does supplementary mean? It means they add up to 180. So when you think of a line, that line is 180 degrees because it goes from 0 to 180. All right? So what is a linear pair? So I would say 3 and 6 are linear pairs, but they're not congruent, so I'm not going to use the same color. Or 1 and 8 are supplementary. Okay? So what that means is that the angle of angle 3 plus angle 6 are going to equal 180. Now this is going to be the measure of both of these, so make sure you say the measure, not just the angle. My bad. Alright? So now let's move on. Now we have corresponding angles. Now these are going to be angles that are congruent to each other, but let's look at some examples. So corresponding angles is kind of like if you had two parallel lines cut by that transversal, you now have two 4 points or 4 corners. So corresponding angles are going to be the angles that are in the same place of each 4 points. So let's say, for example, 1 and 3. Those two are congruent. Or you can say 8 and 6. So again, you can go around that whole thing and they would all be congruent to each other in some way or another. Alright? So we can write that as an example. So we can say angle 1 is congruent to angle 3, or that angle 8 is congruent to angle 6. So the next thing that we need to talk about is alternate interior angles. So this might get a little confusing if you don't understand it fully. So alternate interior angles is very much so dealt with parallel lines. So interior means everything between the parallel lines, and then exterior is everything outside of the parallel lines. So please make sure you are reading them correctly. So when I have alternate interior angles, I'm going to be dealing with that blue highlight, and they have to be along the transversal, the same transversal. So 7 is congruent to 3. And then we're going to say 2 is congruent to 6 because they are alternate. They're inside and they're alternate. They're on the other side. So for your example, you can say that they're going to be congruent. So example is going to be 7 is congruent to angle 3, and 2 is congruent to 6. Alright? So along with that same idea, we also have alternate exterior angles. So exterior, as I said before, is going to be dealt with the pink highlighter. So I'll get rid of this blue highlighter so we don't think about it. And it's still going to be alternate just like the interior. So we are going to say that 1 is congruent to the alternate, which is 5. We can also say that 8 is congruent to the alternate, which is 4. So up here we can say alternate exteriors are going to be congruent angles, and my examples are angle 8 is congruent to angle 4, and then my other example is that angle 1 is congruent to angle 5. Alright? Alright, so the next one we have is same side interior angles. So the important thing to note is that these are supplementary. They are not congruent, they are supplementary, so we got to remember they add up to 180 degrees. So an example, we got to remember that interior means we're only dealing with between. So we can say that angle 2 is supplementary to angle 3. So I would say that the measure of angle 2 plus the measure of angle 3 is going to equal 180. We could also say that the measure of angle 6 and the measure of angle 7 are going to add up to 180 as well. Okay, so that's what that means, alright? So now knowing all that information, if you would like to label this parallel lines with that transversal how you would like so that you can remember, that is A-okay with me. I'm just going to leave this blank for now. Alright, so let's move on to this example. So say we were given this weird looking shape with the parallel lines. So these are parallel, and then we also have these transversals. So we have a measure of angles here. So let's think about how we could solve for those variables x and y. Alright, so the first thing I'm going to notice is that we have parallel lines and then we have that transversal going through. So this transversal is pretty important. Well, one thing that I notice is that they're on the opposite sides of each other and they're between the parallel lines. So we can use alternate interior to prove that they are congruent. So I'm going to say 3m plus 2 equals 4x minus 18. So from here I can solve for x and we can get that number. I want you to solve for x because I know you can do this. So pause the video here and solve for x. So you solve this correctly. You should have noticed that x equals 20. So now we can solve for y, and I'll show you now. So one thing that I notice is that y, or this guy, doesn't have a pair to go along with it. So we got to use two things to get it to work. So one thing that I see is that there's two transversals, so we can use corresponding angles. So this is going to correspond right here. So we now have 4x minus 18 on that side and then 5y minus 7. Well, what did I say about linear pairs? Linear pairs are going to be sitting on that line, so they're going to add to 180. So now we can say that 4x minus 18 plus 5y minus 7 is going to equal 180. You're probably thinking, Miss Smith, there's two variables. How are we going to do this? Well, we know what x equals. We said that x equals 20. So now we can plug it in and we have this whole new equation. And now we can easily solve for y. So now I want you to pause your video here and solve for y. It's basic algebra. I believe you can do it. Alright, so if you correctly solved for y, you would have gotten that y equals 25. So we have x and y, and if I asked you to find those angles, those exact measures, you'd be able to. Alright, all you have to do is plug them back in. Alright, so let's move on to triangle congruency. Now this again is a review from Math 2. So what we can do is say what they are. So SSS, that's going to be side, side, side. It's like a ship but with an extra S. So we have our two triangles. We say that this side is congruent to this side is congruent to this side, and our last side is congruent to the other side. You have to have three sides that are congruent to another three sides, alright? Next, we have side, angle, and another side. So it's like sad, but you're sassy. So you have a triangle and a triangle. So you have your one side, and then you have an angle, and then you have another side. So the thing that you need to mark important about this is that it has to be in that order. It cannot be angle, side, side. It can't be angle, angle, side. It has to be side, angle, side. Alright? So our next one is going to be angle, side, angle. I'm going to move over here. So we have two triangles. Again, we're going to have an angle. We're going to have a side. And then we are going to have another angle. Again, it has to be in that order in order to use angle, side, angle. Alright, our next one is going to be angle, angle, side. So again, we have my two triangles. And we're going to have my angle, my second angle, and then my side. And I realize I'm holding up the wrong numbers on my hand, but you know what? We get it. So again, this has to be in that order. If there is a side in between the two angles, it's something completely different. It has to be an angle, and then an angle, and then a side. Alright, my last one, we have hypotenuse, leg. The important, you have to star this one. This can only be used with right triangles. Cannot work for any other triangle. So you have the hypotenuse is congruent to the hypotenuse, and then one of the legs is congruent to another leg. So you have to prove two things for this one. Alright. So now let's look at these examples. So the first one, we already have a side and another side, so we need to prove one more thing. Well, I can't prove the other side is congruent to the other side, so I'm thinking back to my parallel lines important information. Well, I have two intersecting lines, and I see two angles are across from each other, so that's an angle. So I can say by SAS, they are congruent. So moving on to the next one. We have an angle and a side. Well, could I prove the sides are congruent to each other? No, there's nothing that we can do about that. But thinking back to my parallel lines, I know that this is two lines being intersected to each other, so I know that the vertical angles are congruent. So we can say this is congruent by angle, side, angle. If you're ever having trouble determining which one it is, just read it out. Angle, side, angle. Alright, let's move on to the next one. This one's a little bit different. So we have a side and another side, and then we need to figure out one last thing. Well, one thing that I notice about our triangles is that they're sharing this side. So wouldn't you say that's automatically congruent to itself? Yes. So we can say this last side is congruent to itself, and that would be side, side, side. So SSS. Alright. The next one. I want you to do this one by yourself. I want to see if you catch which one this is. So pause the video here and find which one this is. Alright, if you did this one, you should have gotten hypotenuse leg. The important thing that I saw is that this is a right triangle. So that's the first thing I saw, and I thought, well, maybe I could use hypotenuse leg. I saw that my hypotenuses were congruent to each other, and they shared a leg. So hypotenuse leg was how they were congruent. Alright, so let's look at our last one. We have a side, an angle, and a side and an angle. So I need one more item. Remember, you're always going to need 3 items unless it's hypotenuse leg. So I want you to figure out what is my last thing that I have to prove is congruent. So pause the video here and find out. So if you thought back to those parallel lines, you were correct. You saw 2 lines being intersected by each other. And so you could see that there's 2 vertical angles that are congruent to each other. So now we have an side, angle, angle, or angle, angle, side. So angle, angle, side is how they're congruent. One thing that I will note before I end this video is side, side, angle does not exist. That is a big no. Never say side, side, angle. We will all be very mad if you say that because 1, it cannot be proven true, and it only works for some triangles. But you will never use this theorem. Alright? It does not exist. Alright, that's it for today's video. Have an awesome day and stay safe out there, guys.